Okay, my name is Søren, and if you haven't guessed from my very bright slideshow template, I'm a developer here at Impact. And I'm going to talk to you about Redux, which is a little framework aiming to help you utilize or help you control your state management and data flow in your applications. And just a quick show of hand, how many of you have heard about Redux? Nice. How many of you have ever worked with Redux? Oh, that's awesome. My talk will make sense then because it's pretty introductory. Otherwise, I would have just said thank you and left. All right. The thing I find most interesting about Redux is that it has a very consistent way of managing state and state transformations, and it really helps you control your data flow when applications scale upwards. So what is Redux? Yes, it is yet another JavaScript framework, but not in the same sense as with Angular and React, because it is completely separated from the Vue. It plays well together with the Vue frameworks like Angular and React, though. There's all sorts of plugins in place that help you bind the state kept in Redux with the views expressed in frameworks such as Angular. If you go to the website of Redux, it's described as a predictable state container, and the wording from that comes from its foundation in functional programming, sort of functional programming paradigms, such as immutable data and pure functions. And I'll get into that later, what that exactly is and how Redux uses it. And third point, not the least, it's made by a guy from Eastern Europe. And if you go to egghead.io and look at his tutorials, you'll be greeted by a guy with a very heavy accent. That's very funny, but it's also very helpful because his tutorials are actually really on point. So without further ado, and yes, I brought a beautiful GIF animation. This is Redux, and this is the data flow and how you use it in Redux. And introductory, or in this presentation, I'm not going to go into the middleware layer, which is the brown sort of or the purple patch up there, because it's not actually required to get a sense of what's going on in Redux. The view part of this animation is the application and the container for your application that interacts with Redux. And what happens here is the view sends an action to the store, and the action seeks to describe what's going on in the view. So if you click a button, some action will be sent to the store, and it will be run through this set of reducers in the green box over in the store. And the reducers will sort of describe the logic for the transformation of the state, depending on the action. And afterwards, when it's been run through all the reducers, the new updated state will be propagated to the view, and the view can, or the application can update the interface with the transformed state. So some terminology. To start out with, the store is the only variable in Redux that you'll actually interact with in your application. It's generated from reducers that you define yourself. Yeah. And it's generated from a function in Redux that's very nicely called create store. Makes sense semantically. And what can you do with the store? Well, you can dispatch actions, as I just said, and was highlighted by the animation before. And it also handles the notifying of every subscriber from your application. And how does that look in code? Well, it looks like this. You import the create store from Redux, and then you define a variable, you could call it store, and then you pass it a reducer. that describes how your state is going to transform. And then you dispatch actions to the store and subscribe with some subscription or notification handler. And that's pretty much it. That's as difficult as it has to get. Actions, as I've talked about, are objects describing what happens in your application. So as an example, you could say if you click a button trying to add a product to a basket, that could be described in an action. And actions can include data, but are not required to. Actually, the only required property on an action is the type, and the type is what describes the intent of the action. Optional properties can be used to sort of include per se a product in your action to append to a basket state or something like that. And if you were to translate what I just said into code, it will typically look like this. This is a common pattern in Redux when defining your actions. So you don't actually just define a set of objects, you define a set of functions called action creators, which in turn create the objects, which are the actions. And that's to take part of the annoyance of sort of string comparison away from it, because I'm guessing you could all imagine if you had to define strings all over the place, it could get messy really quickly. Yes, and when dispatching an action, you would then just call store dispatch and then access your action through this set of action creators. So reducers are inevitably the biggest challenge both conceptually and practically when starting out with Redux, because it is somewhat confusing. But reducers as a concept, they describe the state transformations going on in your application and in your store. And they are just pure functions, and if you don't know what a pure function is, that's okay. It's part of the functional programming paradigm, and a pure function is just a function which solely relies on its input arguments to produce its output. In the case of a reducer, that's not it yet, it always takes two arguments: the application state or the current state of your application and the incoming action. And from that action, it will determine how to transform the state into a new state, which is propagated to the view. If you're developing an application and it scales, you'll quickly feel the urge to divide your application into components if you were talking Angular, or different components. And Redux sort of supports this by making it possible to define different substates and different reducers handling those substates. So as an example, you could imagine an application where you had a basket and a set of products, and a user even maybe, and each of these substates would have their own reducer defined to describe how to transform these. And you would combine these with a function exposed by Redux called combine reducers, and it will sort of describe the global state of your application. In code, a reducer could look like this. It's just the middle one, card reducer, we're looking at. And it is simply just a function taking two arguments. And as you can see in the body of the function, we look at the action type and sort of determine how to transform our state according to that. So in the case of add to cart, you would append or add the product in the action to the list or the array of products defined by the state here. And notice how I used the array spread operator here, because the array spread operator is shorthand for concatenating, and that is concatenate treats arrays immutably. And that's pretty critical to developing in Redux, at least it says so. I actually think you can make it work if you don't do it, but if you want your application to perform well, you should actually work with immutable data, because It creates a new reference to the object instead of just building on the old reference you have. And that will make comparison on objects and arrays way lighter on in your components. Yes. Okay, so here comes the scary part. I am gonna code up a really small application for you in vanilla JS, and it's gonna be the good old counter example. So it's gonna be really simple, but should be fun. That's not it. Okay. Wow, that is big. Go to the side. No? Okay. Can you still see? There we go. Okay. I've scaffolded and we don't actually need more space than this, I hope. I've scaffolded some HTML, which simply holds Redux from a CDN over here. You can't see that, but just trust me, it does. And then as the second script, it holds our application script, which we're going to define. But first, let's define our interface, which is going to be really pretty. Just wait and see. We're going to have a button to decrement our state, which is a number. And we're going to have a button to increment it as well. And lastly, I'm going to define an element which will hold our state, which is not going to be set to 0 yet. And to reference it, or to be able to reference it in our code, I'm going to give it an ID of count. So how do we start this? Well, our store needs a reducer to be able to work out how state is going to be transformed. So we can go ahead and start developing that. But just to make a point, that one of the most awesome things about reducers being pure functions is that pure functions are really easily testable, because its output relies only on its input arguments. So let's go ahead and take the approach of test-driven development. So I'm going to make some assertions. And yes, I know I haven't defined the reducer yet, but bear with me. We're going to call or name our reducer counter reducer, and we're going to pass in a 0 as the initial state, and we're going to compare it to this a 0 because it's just going to return the same state it's getting passed in. And if it fails, we're gonna print out state not returned, and that's pretty much it. Let's try and make it run, and we'll get the error we hoped for. Counter reducer is not defined. So let's go ahead and define that. Counter reducer, and we'll make it a function, and this is just an ES6 function. If you don't know it, it's just a smart way of making a function, really. We're going to give it a default state of 0 if we don't pass in a state, and we're going to give it a default action as an object. Okay. So if any of you have ever learned about test-driven development, you always want to watch your stuff fail before you develop. So let's go ahead and do that. And here we go, assertion failed, state not returned. What a surprise. So let's go ahead and fix that. I've simply just returned the state, and if we go ahead and refresh, all our tests, or our single test, passes. Okay, so our counter reducer is not much fun right now, so let's go ahead and define the functionality it should be able to cope with. We're gonna grab our counter reducer again, and first off, let's try to test our decrement functionality. So we pass in a 1 initially, and we expect it to return a 0 because it's going to decrement it by 1. And if it fails, we're gonna print out decrement fails. Not very imaginative, but and now we're gonna actually start working with the actions, because it's pretty hard for us just to rely only on the state to know how to transform this state. So let's pass in an action, and the only property we'll need for this application is the type So let's go ahead and write that. Decrement. And let's go ahead and copy that and do the same for increment. And let's put a 2 here because everything else would be silly. And for semantics, and let's go ahead and run it. Man, this screen is really small. Can you see it? Okay. Both our assertion fails. Surprise. So let's go ahead and implement some logic to actually handle it. As I did in my example when explaining reducers, I'm going to do it as a switch statement, looking at the action type. And just to make it work again, I'm going to return the same state as I put in as the default. So now we're back to the same as we had before, except now we're going to handle some cases as well. And normally, by the way, these strings would be defined in an object, so you don't have to just rely on yourself typing in the strings correctly all the time. But I'm not going to do that because, yeah, I don't want to. Okay, so in our decrement case, what do we want to do? Well, we want to return the state, but decremented by 1. And in the case of increment, we want to do the same thing, but exactly opposite. So this should actually make our assertions run through, and whoop-de-doo, they do. Okay, so our application isn't much fun yet because it's just a function that we can't really use. So let's go ahead and make our application. And I'm going to define this as a class, counter app. And when constructing it, wow, constructor. We're going to first grab the reference to our element in the view to be able to sort of inject the value of the state into it. And that was called, had an ID of count. Yes, and here comes the Redux part. Now we want to define our store, and just going to do that to make it the compiler happy. If we look at Redux in the console, we can see that it exposes 5 functions. And this one is the one, at least it looks like from the name, that's the one we want. And what does this do? Well, it is a function that you can't really see it right now, but it takes in 3 arguments: a reducer, a preloaded state, it says, and an enhancer, which is something to work with the middleware. We're not going to go into that. The only thing we need right now, and the only required one, is the reducer, which we're going to pass in. So redux.create store. And what we could do is we could just pass it in directly, but what fun is that? We want to give our application some dynamic capabilities, so we'll take in a reducer in the constructor and then pass that to it. So if you wanted to make a double counter app, you could do that by just defining a new double counter reducer, which incremented and decremented by 2 instead, and then pass that in. Architecture. And lastly, we're gonna define a variable on our window, which is an instance of the counter app class, capitalized, new. And in this, we're going to pass in our counter reducer, so that should bind it up nicely inside. Last thing we'll need, you would think, to update our view with the internal state would be a subscription to the store. Is that spelled correctly? Subscription, yeah. And that takes sort of a subscription handler or notification handler. And what do we want to do in this? Well, we want to grab our element and set its inner text to the state of the store, store.getState. And the way you grab that is by calling store.getState. And this notification handler is called every time Redux passes an action and its state through all the reducers defined. So when I press refresh here, nothing's going to happen. Type error subscription is not. Nice. Thank you, random person. Subscribe. Let's see if that works. Yes. But still nothing happens. And that's because, as I just said, the notification handler is called at the end of the cycle. So we haven't actually dispatched an action yet. But after we do that, I promise you something will happen. And let's just go ahead and pass in something that makes sense semantically, like init, because it's in our constructor. And when I refresh, hopefully, yes, we get a 0 on the screen, which is the state. But our buttons are pretty boring, so let's make this interactive. We do that by defining two functions. Decrement, we could call it, which is gonna dispatch an action with the type of decrement, just as in our tests. And we're going to do the exact same thing, but opposite, just as before, for increment. And that's actually it. Last thing we need to do is we need to go to our view and bind this to the onClick event handlers. OnClick. So counter app.decrement. And increment for the plus sign. And with a bit of luck, this will work. And everyone is amazed. Thank you. Okay, so I'll make a smooth transition to my slideshow just to do this. And we're going to have another demo, but this one is pre-made. But yeah, this is to show a more complicated example with substates and an actual Angular implementation. And Angular has some pretty sweet stuff implemented to work together with Redux. So I've implemented an app with the Angular CLI, so I'm gonna serve it. And we're just gonna wait for Webpack. Yes. And we're going to try to go to this localhost. And behold, the to-do list. We could add some to-dos like drink cola and show code. And I've already drunk my cola, so I'm going to cross that off. And that goes to the completed section, and the other one is in the active section. Really awesome. So how does this work internally? Let's have a look. Okay, so the best place to start would probably be the root module, and just ignore this because this is just basic Angular setup, and if you haven't worked with Angular or Angular 2 before, it's just going to be confusing. But this part is where we define our Redux store, and just as with the vanilla Redux implementation, we pass in a reducer. Here we do it in the configure store of ng-redux, which is just a wrapper around Redux for Angular to control. And the second parameter is the default state, and I'm passing in an empty object because otherwise it complained. Yeah. And where does our root reducer come from? So this is an example of a combined sort of reducer made up from multiple substates. So as you see here, I grab the combined reducers from Redux, and I use this to sort of combine the two substates that define my global state. And that's it for this part. Our application is made up from two components, the to-do filter and the to-do list, matching up with the two substates. And if we go to that, we can see in this component how Redux or how our components interact with Redux, and it does this in a pretty smooth way with the decorators and so on. But first of all, you dispatch actions by just calling dispatch on ng-redux. So ng-redux just exposes the dispatch function on the store. So there's not much new in that. But the way you subscribe to your state with ng-redux is pretty awesome, I think, because you decorate a property on your component with a substate. So this is the select decorator, and what it does is it lets you define a part of the state of the application that you want to bind to this property, and it does it through an observable, which if you know Angular and Angular 2, you love observables, so that is just good news. And the way you use it in your view is, for example, I have a list of to-dos, and I grab or I repeat over my to-dos observable and pipe it through the async pipe and the async pipe just handles the subscription to the observable for you. So every time data comes through the observable, it will directly just put it in the view. And I do the same thing with the filter observable. I pipe it through the async, and this is a filter I've implemented to just look at the state of the to-do and try to match it to the filter that's implemented. Won't go too much into that because we also need to look at the reducer. And in here I've actually got two reducers, but that's actually a common pattern in Redux, is you define a reducer for every level of substate you have. So this reducer handles the to-do list on a to-do list level, and this reducer handles the to-dos on the single to-do level. So every time I need to sort of transform the state of a single to-do, I call this. Yes. So let's go through this. We take in a state which is an array, which is passed in by Redux itself, and we take in an action which we dispatch through the ng-redux. And if, as an example, if we match to a type of add to do, and as you might remember before, I talked about our action types being defined in an object. This I've actually done here, so we don't have to type the string in all the time. If we match add to do, I'm simply gonna append the payload of the action, which is a to do, as it says here, to the state or the substate of the to-do list. And yeah, that's pretty much it for the to-do list. So I'm gonna go back to the slides. Gonna press play again. And lastly, I'm just going to reflect over the sort of challenges I've had when starting with Redux. So it is a really different way of thinking about state, and it takes some getting used to when first implementing it in your developer stack. And it requires more setup and really strict structure. But if you work with other people, this can also be a very positive thing, because it forces you to develop in a way that everybody understands when you get used to it. Integrating the plugins for the different frameworks like Angular adds even more complexity initially. But when this is done, it also improves the readability of your code by a really nice amount, and it reduces the complexity of view components, because all your state logic is brought into the reducer instead. So you get a slim component, which is probably what you want anyway. Everything I've put up on the screen here today is available on here. So you can go ahead and find that. It's going to be on the video as well. So yes, it includes both the slides and the examples I've implemented. Yeah, so you can go ahead and have a look at that if you want to. Otherwise, I can really recommend the video tutorials done by this guy who implemented Redux. It's really, really good if you want to learn it. And yeah, that's pretty much it. Anyone's got any questions? That took a long time. No?
Yes, of course.
Ask me a question.
Are you pretty new to this Redux? I actually never heard about it before.
Yeah.
But where do you typically use it?
Well, you would use it if your application has a sort of global state that needs to be shown in multiple views.
Could that be a web store?
Yes, it could. Yeah. Try to imagine having a list of products, and when you load in the products, you could put these products into the Redux store, which is simply just a way of putting it into the memory of the client.
Yes.
And when you need to add a product to the basket, and the basket could be reflected in multiple places on your website, you would dispatch an action to the store, updating the state, and then you could subscribe to the store in multiple places. Say you have sort of a little widget on your product that updates with the amount of products of this type in the basket, and you'll have your mini basket or something updating as well. So it's really good. It's really good if your applications have multiple places that subscribe to the same part of the state. Whereas
It updates in real time.
It updates in real time, yeah. And the whole point of Redux is that however complex your applications may be, the data flow stays very simple, because you just dispatch an event to the store, always the same point, and you subscribe to the same point as well every time. So there's nothing going on with the component tree sort of emitting events up through the component tree and so on. You always have the same point of entry, which is really, really nice because it simplifies a lot of things. Anyone else? Back? You in the back?
How do you manage side effects?
Well, yeah, good question. Side effects are managed through the middleware layer, which I wasn't going to go into, but apparently now I am anyway. So the whole point of keeping your reducers pure is to sort of make the store predictable, as it says on the website. So where do you put your side effects, such as updating from a database on the server? Well, you do that in a middleware layer. And the middleware layer lets you sort of inject functionality that gets called before and after your actions. And there's all sorts of middleware to handle different types of side effects. Like a very popular middleware lets you dispatch actions to the store, and which can be functions or async functions, and that lets you contact the server and sort of take control over the action flow in your application. So if you wanted to get a list of products from the server, as an example, you could go ahead and dispatch this async actions through the middleware layer, which Redux will handle for you. And then you could sort of send an action that lets your application know that products are loading. So you could show a spinner or something fancy like that. And once the products then are loaded, you could dispatch another action and load in the products into the store and into memory. So short answer, you use the middleware layer. You never use the reducers, because that takes away from the predictability principle of Redux. Did that cover? Yeah. Okay. Anyone else? Yes?
What about collaboration between Redux and JSON?
JSON?
Yeah, I mean, are you able to store in JSON in a JSON?
Yeah, in a JSON file.
Yeah.
I don't know about files. You probably make some middleware layer that writes to a file, I can imagine.
Okay.
But yeah.
You can read and write to the
Yeah, you can. Yeah, exactly. So that's actually a good example of where you would use a middleware. So you can go ahead and fetch a file in your file structure through the middleware, and then once it's loaded in, you load it into the store with an action. So you could do that, yeah, definitely. Yes?
You talked about you could combine reducers.
Yeah.
Did we see an example, or was that not the thing?
Yeah. I'll just show you.
Yeah, just to understand what does it mean to combine reducers.
So a reducer defines a certain part of the state of your application. So in this, not this place, in this place we have a filter which is this, and we have a list which is this. And those two are different substates of your application. And you combine these to make up the global state, because in Redux you always have one single object defining your whole application state. Yes. Can you repeat the question?
So the root reducer is
The reduce.
reducers.
Yeah, it's a combination of the substate reducers. Yeah. And what Redux does, is once an action is dispatched to the store, it runs the action through every reducer defined in every level of your application. Yeah. So this key.
So the same action is passed to both reducers, but
Yeah, it is.
reacts to it.
Yeah, exactly, because that's the only place where you actually have a string comparison in the switch statement matching it. Otherwise, that's the reason why you would always need to return the state, because if nothing is returned, the substate is set to nothing. So if you can imagine, if you return nothing, you're just going to get a null pointer somewhere in your state, and you don't want that. Did that cover?
Yeah.
Okay.
So you have to be careful to not have the same action types in multiple reducers.
Yeah, you wouldn't have that. In big applications, I haven't really worked with Redux in very big applications before, but I can imagine you would make up a sort of a namespacing pattern, yeah, to make it comprehensible, because otherwise you'll probably go insane trying to keep track of all your string comparisons. Yes?
Do all the reducers get the global state, or can they also have substates like so that you have a sub-area of the state object that you can separate?
The reducers actually, Redux is very smart about that, because this is not the global state of your applications. All the reducers get the substate of the reducer. Yeah. So Redux figures that out for you when you use the combined reducers.
Do you subscribe to a part of the state, or?
In your component, you describe through the select statement which part of the state that you actually subscribe to. But in the subscribe function, you get the whole state every time, and you have to filter it for yourself. So in the case of my vanilla Redux example, I get the whole state. Luckily for me, here the state is the only thing. The global state is the only thing I want. But if I had a larger state made up of several substates, I would just dot myself through this. So I would say dot to-do list, and I would grab it like that. Yes.
Yeah. So give it up for Søren.